We are writing rules for exponential functions. Exponential functions. Okay. We need to remember what we learned about graphing yesterday. And I'm going to graph just a little one over here, actually on a sticky note, so that we can remind ourselves of what's going on. So if we have y equals 2 to the x power, we're going to make a table, x, y, -2, -1, 0, 1, and 2. Okay, now we're replacing the exponent x with these numbers. So y equals 2 to the -2 power. The way we would deal with negative exponents is put them over 1 and flip them 2 to the second. 1 over 2 to the 2 squared is 4, so that's 1/4. Okay, y equals 2 to the -1 power. Put it over 1. Use the reciprocal, 2 to the first. 2 to the first is just 2, so that's 1/2. Y equals 2 to the 0 power, which is 1. Y equals 2 to the first power, which is 2. Y equals 2 to the second power, which is 4. Okay, there's... And then we graph, obviously. So -2 is at 1/4. Well, 1/4 of the way to 1 is like there. Half of the way to 1. 0, 1, 1, 2. Seems I'm losing my voice. That's fantastic. Okay, and that is what an exponential curve looks like. Two things we notice right off the bat. Okay, 0 is 1. That means there's nothing multiplied out front of the exponent. And each time we are, 1 times 2 is 2. 2 times 2 is 4. 1/2 times 2 is 1. 1/4 times 2 is 1/2. So that gives us our base. Okay, let's see if we can write a rule for this function. Okay, looking at 0, it is 1. So 1 is going to be out front. 1 times our exponent. Okay, now we need to figure out what our base is. What do we need to multiply 1 by to get 11? Well, we need to multiply it by 11. Does that continue to work? Is 11 times 11 121? Yes. Is 1/11 times 11? Well, the 11s would cancel out on top and bottom, so it would be 1. And if it worked that many times, it's probably going to work this time. Okay, so our base is 11. Okay, questions with that? Okay, looking at our 0, well, 1/4 is going to have to be out front, because anything to the 0 power is 1. In order to make that 1 be 1/4, we would have to multiply it by 1/4. Now, we need to figure out what our base is. Well, I'm going to go over to this 1. What do we need to multiply by to get 2? Well, we need to multiply by 2. Now let's see if that works. Is 1/2 times 2 1? Well, 1/2 plus 1/2 is 1, so yes. 1/4 times 2 is 1/2, and 1/8 times 2 is 1/4, so our base is 2. Okay, we need to graph the function and identify its domain and range. So, making an xy table, -2, -1, 0, 1, and 2. Okay. 12 to the -2 over 1, flip it, 1 over 12 squared. Well, 12 squared is 144. That is extremely close to 0. Okay. 12 to the negative 1 power over 1. 1 over 12 to the first. 1/12. Okay, that's still really darn close to 0. Okay, 1/12. Okay, anything to the 0 power except 0 is 1. Okay. Oh, we're going by 2s, careful. Okay, and then 12 to the first is 12. So 10, 11, 12. And we're not going to be able to fit that next. That next point on there, so I'm just not going to do it. Okay, now we need to identify its domain and range. Domain is x values. Okay, I could keep putting in x values negative, right? And I could keep putting in x values positive. So the domain is all reals. And it's going to be for all of these. The range is what's different. Range. Okay, well, my smallest value is 1/144th, but I could keep putting in -3, which would be 1 over 12 to the third, and -4, 1 over 12 to the fourth, 1 over 12 to the fifth, 1 over 12 to the 100th. So we're going to be getting closer and closer to 0, so y is greater than, but we'll never get to 0, and we'll never be negative, so y is greater than 0. Okay. So, oh man, decimals, why did I do this to myself? X, Y. -2, -1, 0, 1, and 2. 3.1 to the -2 power is 1 over 3.1 squared, which is 1 over 9.61, which is basically a 1/10, okay? 0.10, okay? 3.1 to the -1, which is 1 over 3.1 to the first, which is 0.322. 322, okay. Oh, 0 point, whoops. Ignore that. Oopsies. Okay. Anything to the 0 power is 1. Okay. 3.1 to the first power is 3.1. 3.1 to the second power is 9.61. Okay, so -2 is 0.1. -1 is 0.3, so a third of the way, close-ish. Okay, 0 is 1. 1 is 3.1. 2 is 9.6, which is way off our curve, okay? Okay, so again, domain, all reals. Okay, range, y is greater than 0 again. Okay. I wonder when we'll get to one that is not like that. Okay, x, y, -2, -1, 0, 1, and 2. Okay, so 9 halves to the -2. Well, that's 9 to the -2 over 2 to the -2. Flip it, 2 squared over 9 squared, which is 4 over 81, which is, I don't even know. .04. Okay. 9 halves to the -1, 9 to the -1 over 1, 2 to the -1, 2, 1, 9, 1, 2 ninths, which is 0.2 repeating. Okay, anything to the 0 power is definitely not 0, is 1. I was going to write it to the 0 power, and then I didn't. Okay, 9 halves to the first. Distributing that 1, it's 9 over 2, which is 4.5. Okay, 9 halves to the second. 9 squared over 2 squared. 81 over 4 is 20.25. Okay, graphing all of these. 0.04, that's really close to 0. 0.02, like 2/10 of the way, oh my goodness. 1, 4.5, 4.5, and that other one's way off there. Oh, I missed the dot, but that's right. Okay, again, domain all reals. Range y is greater than 0. Okay, by order of operations, the exponent comes first and then the negative, x, y. -2, -1, 0, 1, and 2. Okay, so, no parentheses. Negative 5 to the -2, putting it over 1. Negative 1 over 5 squared. Well, negative 1 over 25. Okay. 1 divided by 25. So that's negative 0.04. Okay. Negative 5 to the -1 over 1. Flip it. Negative 1 over 5 to the first, which is negative 1/5. Okay. Anything to the 0 power is 1. So 5 to the 0 power is 1 with a negative out front is -1. Okay. Negative 5 to the first. Well, 5 to the first is 5, so that's -5. Negative 5 squared. Negative 25. Okay, so negative 0.04, really close to 0. Negative 1/5, a little less close to 0. 0 is -1. 1 is -5, and negative 25. Okay, notice it is the same curve, it's just upside down. So, domain, all reals. We can still put in any x value we want. Range. Okay, we will get closer and closer and closer to 0, but we will never get there. Okay, but we will continue getting more negative, so y is less than 0 forever. Okay. X, y, -2, -1, 0, 1, and 2. Negative 3 halves to the -2. Negative 3 to the -2 over 2 to the -2. Negative 2 squared over 3 squared. Negative 4 over 9. Okay, that's 0.4 repeating, negative 0.4 repeating. Okay, negative 3 squared to the -1. Negative 3 to the -1 over 2 to the -1. Negative 2 over 3. Negative 0.6 repeating. Okay. Anything to the 0 power is 1, so -1. Okay. Negative 3 halves to the first, which is negative 3 halves, which is negative 1.5. Okay. Negative 3 halves squared, negative 3 squared halves squared, negative 9/4. Well, 9/4 is is 2.25, negative 2.25. Okay, so negative 0.4, negative 0.6, negative 1. Okay, negative 1.5, negative 2.25. That's a lot slower. A lot slower. Okay. Oh, domain range. Domain, all reals. Range. Y is less than 0. Okay. Yay, we're getting to something a little more complicated. Negative 2, negative 1, 0, 1, and 2. 5 times 2 to the negative 2, well, over 1. 5 times 1 over 2 squared. 5 times 1/4 over 1, 5/4. So that's 1 and 1/4, which is 2/5. Okay. 5 times 2 to the negative 1 over 1. 5 times 1 over 2, putting 5 over 1. 5 halves, which is 2.25. 5 times 2 to 0. Well, 2 to the 0 is 1, so 5 times 1 is 5. 5 times 2 to the first, well, 2 to the first is 2. 5 times 2 is 10. 5 times 2 to the second, 2 to the second is 4. 5 times 4 is 20. Okay, so negative 2 is 1.25, 2.25, 5. Careful, we're going by 2's. 10. Okay. Domain. All reals. Range. Y is greater than 0. Investments in a savings account. You deposit $500 in a savings account that earns 2.5% interest, compounded yearly. Find the balance in the account after the given amounts of time. Okay, so this is the equation that we're going to use. Okay, where principal is the amount invested. R is the rate. And T is time. Well, A is the amount in the account, okay? So we have $500, so A equals $500. Okay, 1 plus the rate is 2.5%. How do we write 2.5% as a decimal? Well, we move the decimal place 2 places, so that is 0.025 to the time, and the time in this case is 1. Well, simplifying that, we have 500 times 1.025 to the first, which is just 1.025, so 500 times 1.025 is $512.50 after 1 year. Hey, that's free $12.50. That's pretty sweet. Okay, now let's find out after 5 years. $500, 1 plus 0.025 to the 5th. Well, first step, 500, simplify that, parentheses, 0.025 to the 5th. Okay, 1 1.025 to the 5th power. Okay, that is that. So 500 times 1.1314028, whatever, and far enough. So then I'm just going to multiply that times 500 in my calculator, and I get $565.70. Your bank always rounds down. Yay. Okay, so a free $65. That's pretty sweet. Okay, $500. 1 plus 0.025 to the 20th. Oof, this is going to be pretty awesome. 1.025 to the 20th. Let's find out. Okay, 1.025 to the 20th power is 500 times 1.6386 and so on. I'm just going to multiply it by 500 in my calculator. So 819.30. Okay, your rank always rounds down. That 0.8 of a penny, it doesn't count. Okay, so that is an extra $319 for free. That's awesome. Okay, profit. A business had a profit of $10,000. Then the profit increased by 8% each year for the next 10 years. Well, we're going to use the same equation. This is our exponential growth equation. So 10,000 times 1 plus 8% as a decimal is 0.08 to the t. Okay, profit. P for profit this time. Okay, use the function to predict the profit in 2009. Okay, profit equals 10,000, simplifying the parentheses, 1.08. Well, in 2009 is 9 years from the beginning, so 9 is t. So 1.08, or 1/800th to the 9th power. Okay, 10,000 times 1.999 times 10,000. That's 3 zeros, right? Okay. Is $19,990.04. That's some pretty good profit. Okay. Exponential growth. Yay!